In this narrated presentation, we will discuss algebraic thinking and reasoning, as well as ways to authentically assess mathematics achievement. In kindergarten through third grade, algebraic reasoning, also called algebraic thinking, involves forming generalizations from experiences with number and computation and formalizing these ideas with the use of meaningful representations and symbols. Algebraic thinking is used across all areas of mathematics and even into other content areas. Although algebra is often considered a separate strand of the mathematics curriculum, algebra can and should be approached as an integral part of all mathematics. Pre-K through third grade teachers need to build students' firm understanding of the arithmetic symbols. The addition, subtraction, multiplication, and division symbols are of primary importance, but perhaps the most significant is a deep understanding of the equal sign. This is one of the most important symbols in mathematics and is introduced in kindergarten. However, too often children have a very poor understanding of the equal sign and its symbolism of the equivalence relationship. This is so important because it focuses on students seeing the equal sign as the relationship of the numbers and a sign of balance. Variables simply represent unknown values or quantities. This can be done with or without the use of x. Bring it to the most basic addition equation. Let's say Sally needs 12 pencils and she already has 7. To determine how many more pencils Sally needs, you may say 12 minus an unknown equals 7. Or you could do the inverse and solve by saying 7 plus what other value equals the total of 12. Either way, you have essentially used algebraic reasoning to solve the first grade math problem. Although variables aren't included in our math standards until 5th grade, the introduction of this type of thinking should be woven into mathematics instruction as soon as it is developmentally appropriate for the young learner. Most commonly, that's by kindergarten to 1st grade. When variables are introduced, it is important that students are conceptually able to recognize that the variable stands for the number and that it's flexible based on the situation. Therefore, if 3 plus x equals 5, x equals 2 in this situation, but in the next situation, it can and likely will represent a different quantity. Math literacy requires a deep and fundamental understanding of numbers and number sense. This can be strengthened through proficiency with properties and operations. During the early years, it's important that our young learners make sense of these properties as they'll be foundational for future math achievement. We will discuss 4 main properties: commutative, associative, and additive properties, with a little bit of distributive properties, although that is primarily a focus on K3. Commutative simply states that when you add 2 numbers in any order, you'll get the same answer. 2 plus 3 equals 5, and 3 plus 2 equals 5. Although this seems very simplistic, it is important to teach this explicitly, providing hands-on manipulatives and concrete examples to help conceptualize what can be an abstract concept for the early childhood learner. The associative property addresses multiple numbers in an addition sentence, stating that regardless of which 2 numbers you add first, the answer will be the same. For example, if you add 5 plus 4 plus 3, and you do the 5 and 4 first, you'll get 9 plus 3 equals 12. If you shuffle the grouping of your first step and add the 4 plus 3 and then the 5, the answer will still turn out to be 7 plus 5 equals 12. The sum is unchanged. Additive property simply states when you add 0 to any number, you get the same number you started with. And when you subtract 0 from any number, you get the same number you started with. Distributive property is good for multiplication and division, and that can be addressed more fully in your textbook. Again, it is important that students have a solid understanding of these properties to help them as they advance to more complex mathematical thinking. As you infuse algebraic thinking and reasoning throughout your math instruction, be sure to implement varied and frequent assessments. These should be meaningful, relevant, and purposeful. Use a wide range of formative and summative assessment tools, and then let the data you collect from these assessments drive your instruction. Remember, you are likely one of your students' first algebra teachers. You have both the luxury and the liability of designing and implementing quality math learning experiences shaped to nurture algebraic reasoning. And above all, you're tasked with the gift of instilling a love for mathematics in your young learners. View algebra not as a subject, but as a way of life, and embrace the growth mindset to help support you and your students' journey to math literacy.